Hello, I'm Dr. Christopher Galea. I'm a research scientist here at Princeton Satellite Systems, and today I'll be presenting to you about our 27.12 MHz Class E RF board, which is a product you can buy online, and I'll demonstrate it for you today. So to begin, we have the 27.12 MHz Class E RF board. So this is the main part of the product. Then we have this Adafruit, this Adafruit breakout board, which is going to be the clock generator for the Class E board. This is a small SMA connector that will be used to connect the clock generator and to an SMA cable. And lastly, an SMA cable of 1 foot will be included in the package as well in order to connect that connector to the board. So first, you're going to take the Adafruit board and take the SMA connector in order to, you're going to put that on the board, slide it on like this. We're going to use clock 0 in this case, but really it's up to you. And you're going to solder those connections. Also, we're going to take this attachment piece that we'll use in just a bit and connect it, take the short end and connect it to these. You may have to remove one pin. And you're going to solder those connections as well. This will result in something like this. So it shows the connector soldered as well as these attachment pins soldered. Next, we're going to connect that Adafruit board to a microcontroller of choice. In this case, I'm using a Raspberry Pi, but it's up to you about what type of microcontroller. So I connected this attachment piece now to a breadboard, and I'm using that breadboard to connect a 5 volt in, a ground, SDA, and SCL. Next, we're going to set up the actual Class E board. I'm going to mount it on these little mounts over here. You can choose your mounts of choice. And we're going to take a 5 volt and ground and put them into what's labeled the plus 5 volts over here, and also the ground over here. So I'm just taking these right from the Raspberry Pi. You can use them right from a power supply as long as you maintain the 5 volts. Next, we're going to take the power supply output and put those into what's labeled the VDD and the A ground, which is more of an analog ground. And so this is going to drive the voltage of whatever RF signal we're going to get out. Lastly, we're going to take that SMA cable from before and connect it to the clock 0 that we talked about. And on the other side, we're going to connect this to what is labeled the PWM. This is the input of the Class E board. This will essentially send in a square wave of 27.12 megahertz. Lastly, you would take your output. You can bring that to any output of choice. In this case, I have it going through an attenuator and a feed-through termination into an oscilloscope. That is up to you. So this is just a note that the power supply, Raspberry Pi, and oscilloscope and load are not included in this. And so those are your choice. Now I've turned on the power supply, the oscilloscope, and also the Raspberry Pi. I have a code that I'll supply that's part of the data sheet, and now it's running. So I'm going to turn on the power supply, and this is going to go to 20 volts. And voila, you see a nice sine wave that is produced on the oscilloscope. And this is the RF output at the 27 megahertz as recorded on the oscilloscope. And then if you happen to have a fast probe, so this is a probe that goes up to 200 megahertz, you can actually resolve the voltage signal on top of the capacitors. So right here. And you can see that they have a nice peak with that near zero voltage switching. They're kind of flying over to zero. In this case, a little bit of overshoot. And we essentially get efficiencies in the 80s%. Thank you for watching this video. If you would like to look more into this board, you can purchase it online at psatellite.com. And if you have any questions, feel free to reach out to info@psatellite.com. The board purchase includes the code as well. Thank you.